This is section 11.2, notes day 1, and we're going to start multiplying fractions together. So multiplying fractions with variables is the exact same as multiplying fractions without variables. So if I had something like 1/2 times 3/4, what I need to do is just multiply straight across. So 1 times 3 will be 3 over 2 times 4 is 8. So that's how you multiply normal fractions without letters. Works the same way when you're multiplying fractions with letters. So 6 over 8 to the second times negative 2 over 8 to the third. I'm going to multiply straight across. So 6 times negative 2 will give me negative 12 over a squared times a to the third. Remember, when you multiply exponents, you actually add them together. So 2 plus 3 will give me a to the 5th. That is my multiplied fraction. The next step is to state the excluded values. Now, we did this a couple days ago, and so I'm going to take the bottom part of this new fraction and set it equal to 0. So a to the 5th equals 0. So what number to the 5th power equals 0? Well, there's only one number that works, and that's going to be 0. So a equals 0 is an excluded value, or a value that does not work when you plug it in. Example 2. Now we have more than one term in our fractions. So it's asking, what is the product of x minus 7 over x times x minus 5 over x plus 3? The first thing I'm going to do is put parentheses around anything that has more than one term, because those are a package deal. Okay, so multiplying this is actually pretty easy. I'm going to keep the package deals together. So on the top, I will have x minus 7 and then x minus 5 over x, and then again a parenthesis x plus 3. That's my simplified fraction. Ooh, doesn't it look fancy? Okay, for the excluded values part, I have to take the parts on the bottom and set them each separately equal to 0. So my first part is this x that's not in parentheses, and I just set it equal to 0. So one of my excluded values is just 0. Then I take the parenthesis part, the x plus 3, and set that equal to 0. Now I do have to solve, so I'll subtract 3 from both sides. So x equals negative 3 is my other excluded value. So far, not so bad. Example 3 is where it gets a little bit confusing for some people. It says, what is the product of x plus 5 over 7x minus 21 times 14x over 2x plus 3x, x squared plus 3x minus 10. Now, it does give you a hint that you want to factor as much as you can first, and then cancel or cross out anything that's the same on top as it is on bottom. So, to do this, I'm going to start with this top left part. So, x plus 5. Is there anything that I can take out of the x and the 5? Other than 1, there's nothing. So I'm just going to leave it as x plus 5, but I am going to put the parentheses around it because it does have two parts. 14x. Is there anything that I can simplify there? Nope. So I just write 14x behind it. Not in parentheses because it is not a grouping. It's not two parts. Then I draw my fraction bar. On the bottom, what goes into 7x and 21? Well, a 7 does, so I can take out a 7. And that leaves me x minus 3. Now this bottom has 3 parts, an x squared, an x, and a number, which means I'm going to use the x method of factoring. So on the top of this x, I should have negative 10, and on the bottom, I should have a positive 3. So what two numbers multiply to a negative 10, but add to a positive 3? And that answer would be 5 and negative 2. And because there's no number in front of the x to the second, I can go directly into my factors, which are x plus 5 and x minus 2. Oh, I need to extend my fraction bar a little bit. So now that everything that possibly can be factored is factored, I look for things to cross out. So the big thing that I can cross out is x plus 5. It's same on top, same on bottom. I cannot cross out these other two because I don't have anything on the top that matches them. But on the bottom, I have a 7, and on the top, I have a 14. So I can actually simplify this because 7 goes into both. So that would change this into a 1, and that would change this top one into a 2. So that means what's left on top is going to just be 2x, and what's left on the bottom will be 1, and then these two parentheses, x minus 3 and x minus 2. Now, do I need to have the 1 out front here? No, but it helps me remember that I did simplify this 7, that it didn't just disappear. I was able to take it out of both the top and the bottom. Okay. Example 4 wants to know what the product is of 2m plus 5 over 3m minus 6 times m to the second plus m minus 6. Now, notice how this second part is in a fraction, but just like any old numbers like 2, if I wanted to write that as a fraction, I just put it over 1. I'm going to do the same thing here. Make it a fraction so it's easier to multiply just straight across. My next part is to factor everything that I possibly can. So, 2m plus 5. Is there anything that I can take out of both 2 and 5? Nope, don't think so, so I'm going to write it again. But remember my parentheses, because they are two parts. And then on this side, I have m squared plus m minus 6. Well, there's 3 parts, so I'm going to use my x term factoring. I'm going to put negative 6 at the top and a positive 1 at the bottom. So 2 numbers that multiply to negative 6 but add to positive 1. I believe that is 3 and negative 2. So because, again, there's not a number in front of my m to the second, I can go ahead and write that right into parentheses. M plus 3 for the positive 3 and m minus 2 for the negative 2. Over this bottom one, I have 3m minus 6. What goes into 3 and 6? Well, that's a 3. When I take that out, that leaves me with m minus 2. And this 1, well, I can just do 3 times 1, which just leaves me 3. I don't need to write out the 1 again. So now I'm looking for things to cancel. Well, I can cancel out the m minus 2's. 3 does not have another singular number up here to cancel with, so I cannot cancel that one. These two parentheses don't have a matching parenthesis down below, so there's nothing more I can do other than rewrite. On the top, I have 2m plus 5 and m plus 3, and on the bottom, I'm only left with 3. So that is my simplified fraction.